So now your base 10 table for skip counting is completed. Should look like this with the numbers. And I want to point out various important features of this table. The first thing we talk about is the main diagonal, which starts up here in the upper left-hand corner and goes all the way down through the diagonals down to the bottom right-hand corner. And those are all the perfect squares: 0 times 0, 1 times 1, 2 times 2, 3 times 3, all the way down to 9 times 9. And so those are interesting because this main diagonal, first it's the perfect squares that you're familiar with, but this main diagonal breaks up the whole table in two pieces. And those two pieces that are off the main diagonal, there's this big triangular area, which are the shaded boxes. Sorry, that was my cat. We have this big triangle down below the main diagonal, the shaded pieces. And then we have the part that's above the main diagonal, the non-shaded pieces. And the first thing to recognize is that every row that is in the upper part is matched with a column into the lower part. So what this does is it shows us the commutativity of multiplication. So 2 times 1 is the same as 1 times 2. So here's 2 times 1, here's 1 times 2, you get the same result. And so you could have completed this table by skip counting down the columns instead of skip counting across the rows. But I have you skip count across the rows because it matches up better with using the numbers across the labels across the columns to help you skip count. So there's that. But the symmetry also that is involved, you can see it across the main diagonal. So I see that if I make this perpendicular to the main diagonal, I see that these two values match. I see that that value matches with this value. So it's like if we put a mirror along this main diagonal and we looked in the mirror from this side, we would see this exact information reflected from this side. So that's the symmetry that's showing up. And it doesn't have to be across a split like this. It also works across the main diagonal going up in this direction and down in that direction. So again, if I have the mirror here and I'm looking at it, I see that on the other side of the 9 there, there's the 8, the same I see as the 8 there. So that's some beautiful symmetry. And that's just kind of fun to see, but again, it's showing us the commutativity of multiplication. So one of the neat things knowing that the symmetry is here means that you only really have to fill out half of the table. If you know the main diagonal and you know 1/2, then you know the other half because of the symmetry. That's an important thing to notice. It cuts down on the amount of work that you have to do. The other thing that we're going to talk about in the instructions later on is, or in the lecture, is the fact that when you're at the last column here, or the bottom row across here, these are all multiples of 9. And notice that because we're in base 10, if we work in base 10, if we subtract 1 from it, we get 9, which is the last digit in what we have for our base. And so we look at this and we say, okay, look, the last column are all the multiples of the last digit. And we see that if we think of them as 0, 0, 0, 9, then the ones place counts from 0 and then 9, 8, 7, 6, 5, 4, 3, 2, 1. And the tens place goes 0, well, we can just ignore that part, but let's say 0, 1, 2, 3, 4, 5, 6, 7, 8. So they all add up, all the digits add up to 9 each time, 8 plus 1, 7 plus 2, 6 plus 3, and so on. And so the ones places are decreasing as the tens places are increasing. Pardon my cat in the background. She's Siamese and she's very loud. She just likes to make noise. Okay, so there we have it, and we'll talk more about that and the why it happens in the lecture after this, using the base blocks to understand it. So thank you much. Bye to my cat. Good luck, and let me know if you have questions.